Hello, Mindsetters. Welcome to today's Maths Literacy Show. Today we have a special revision lesson on measurement. We have selected highlights from lessons shown earlier in the term to help you revise. Please post your comments and questions on our Facebook page on facebook.com/learnextra or on Twitter @learnextra so we can help you with your revision. You can also download the notes for today's show from learn.mindset.co.za or click on the link on our Facebook page. Now it's time to get on with today's lesson.
Some months ago, I read this in a magazine, okay? And I'm not allowed to tell you which magazine. Obviously, we're not allowed to, because then we'd be giving the U magazine free advertising. Okay, so let's have a look at this. Now, James, read it to me.
Now officially the world's biggest coffee mug, this gigantic container holds a staggering 13,000 liters of the caffeine-laden liquid. The mug is 3 meters tall and 2 meters wide in diameter.
Okay, here's our mug. Right. Now normally, when you read a magazine, when the normal person reads a magazine, they read it and say, wow, that's incredible. This mug can hold 13,000 liters of coffee. Imagine drinking 13,000 liters of coffee every morning. Okay? Do you have a cup of coffee in the morning?
I do.
I know, and it shows in the classroom. Imagine if he had 13,000 liters of coffee in the morning. Eesh, well, first of all, he'd have to wake up very early to drink all that. And second of all, he'd need a big urinal at school to get rid of it all. Okay. So, looking at that, normal person reads and says, sheesh, that's a lot of coffee. But we are not normal, are we, James?
We're not normal, we're different. We're special.
Different. Okay. And our difference is this, that we maths lit students, and we don't take anything for granted. So when I read this, I thought, I wonder if this article's true. Does this really hold 13,000 liters of coffee? Let's do a maths calculation. And it was just at that time that I was setting a test paper for my grade 11s. And James, you'll remember this question from last year. Okay. And suddenly I thought, this is a great question. Let's slap it in the exam. And the question was this. Given that 1 liter of liquid fits into 1,000 cubic centimeters, prove that the statement given about the height and the width of the mug is correct if the mug holds 13,000 liters of coffee. Okay. Then they tell us this. Remember, the volume of a cylinder is equal to pi times r squared times height. Okay. So in the beginning of the session, I told you we're looking at area and perimeter. Now suddenly we're asking you a question about volume. But volume stems off this whole concept of area. Because to find the volume of a cylinder, I've got to know the area of the
base
first. Absolutely, James. And then to find the volume, I times the base by the
height.
Absolutely. So it's area times the height. So let's try this question. So we want to know, what is the volume of the cylinder? Well, volume we told is pi, but instead of pi, James, I'm using
3,14.
3,14 times the radius. Now, James, we told, okay, that the mug, let's go up, what was it? Was 3 meters tall. So this distance here is 3 meters, okay? And let me choose a different color so it stands out a bit more. And the width is 2 meters.
2 meters.
All right. Now, James, another name for the width of the mug is the?
Diameter.
Diameter. Absolutely. Oh, you're quite sharp tonight.
Hey, so I'm always sharp.
All right. So the diameter. Now, the diameter is 2 meters. If the diameter is 2 meters, what is the radius?
The radius will be 1 meter.
Absolutely. So it's going to be 1 meter, and we're going to square that.
Yeah.
Okay? Times the height. What was the height of the mug?
3 meters.
3 meters. Absolutely. And this now will tell us how many meter cubed of coffee is in that mug. I never thought I'd say that about coffee. Okay? But let's have a look at it. All right. So, James, we're going to do it with the calculator. Why?
Because that's what we do in Math Lit.
That's what we do. 3 times 1.4 times 1 squared times 3 equals, and we get an answer of
9.42 meters.
9.42, and say that last bit again.
Meters cubed.
Brilliant. Meters cubed. Why meters cubed, James?
Because volume's always in meters cubed.
Absolutely. And area is always in?
Meters squared or...
Absolutely.
squared.
Okay. So we know we've got 9.42 meters cubed. But we haven't worked out how many liters are in that. So we're going to have to do a conversion. And let's have a look at the question. The question says to us that 1 liter is the same thing as 1,000 centimeters cubed. So we're going to write that here. 1 liter, let's write it on the side,
1
is
liter
equal to 1,000
centimeters cubed.
James, I have a problem. What's my problem?
You got it in meters cubed there.
I've got it in meters cubed. Absolutely. So I've got to change that meters cubed into,
Centimeters cubed.
and I think we'll do that after the break.
I think so, sir.
So we got as far as this, where we worked out that the volume of coffee that can be contained in that mug is 9.42 meters cubed of coffee. But James said we had a problem. And what was the problem, James?
It's in meters cubed, not centimeters cubed.
Okay. Because our question said 1 liter is 1,000 centimeters cubed. But our answer was in meters cubed. So James, what must I do with this meters cubed?
You have to times it by 100
Okay, why? What are we doing? We're busy changing it to
centimeters cubed.
centimeters cubed. So we're going to times it by 100. Anything else?
And 100 again.
Oh, that's interesting. Anything else?
And 100 again.
Oh, are you just stuck, or is there a reason you said that?
Now let's go for it, sir.
Hey?
100, 100, 100.
100, 100, 100.
100,
But you
sir.
know why you did that.
Probably.
Okay, James is actually quite clued up. The reason why he said we must change it to 100 and times 100 again and times 100 again, because we're not simply changing meters to centimeters, but we're changing meters cubed to centimeters cubed. And you'll remember that from your grade 10 and grade 11 year. Okay, so away we go. And again, we don't want to get confused, James, so let's just use the calculator.
Exactly,
Right.
sir.
So times 100 times 100 times
100.
100 again. Okay, and you should be able to do this in your head, but if you can't, it's going to be 9,420,000. Okay, so 9,420,000 what, James?
Centimeters cubed.
Centimeters cubed. Brilliant. But now here's the exciting thing, because now that we've got our volume in centimeters cubed, we can change it to liters. How can we do that, James?
Well, you know that 1 liter is 1,000 centimeters cubed.
Okay, cool. So 1 liter is 1,000 centimeters cubed. So what are we going to do with that 9,420,000 centimeters cubed?
Divide it by 1,000.
Cool. We're going to divide it by 1,000 to work out how many liters. And when we do that, what do we get? 9,000?
420 liters.
Absolutely. Okay. So that is how much coffee that mug can actually hold. Let's have a look at the question, shall we? The question was, given that the 1 liter of liquid fits into 1,000 centimeters cubed, prove if the statement given about the height and width of the mug is correct if the mug holds 13,000 liters. Does this mug hold 13,000 liters, James?
No.
Not at all. It only holds 9,420. So, the author, do we call them an author? What do we call
Author.
someone who
The
writes?
author. The reporter.
A reporter, yeah.
The reporter.
So the reporter who reported that a mug 2 meters wide, 3 meters high, can hold 13,000 liters of coffee is incorrect. They should have done mathematical literacy when they were at school. Would you agree?
I approve, sir.
Okay, guys, I hope you're enjoying this revision session. If you need help, remember to post on the page or send an email to helpdesk@learnextra.co.za. Now it's time to take a quick break, but don't go away. We'll be right back. Welcome back, guys. We have some great news to pass on to you. We will be bringing you winter school from the 30th of June till the 20th of July, starting at 10 a.m. every weekday. To get the full schedule, visit our website, learn.mindset.co.za, and look for the winter school link. Join us. It's going to be a lot of fun. But now it's time to get back to the lesson.
And on that note, let's have a look at question 2. Now, consider the diagram below, which illustrates a kiddie pool surrounded by concrete paving with a fence surrounding the area. Okay, so let's have a look at that. Let's explain what that question is saying. This question is saying we got a little kiddie pool, all right? And you can see that that kiddie pool is made up of 2 different shapes. James, what
Yes.
sort of shapes would you say they are?
It's a rectangle
Okay, there's a rectangle. Can you see the rectangle there? That's fantastic. And
and a semicircle.
brilliant. So we got our little kiddie pool over here, and surrounding that pool there's a black line which represents a
Fence.
fence. Okay. Why do we have a fence around a pool?
So that not random people can just come in and swim. Or no, so it's so the kids don't get into the pool area and have an accident in the swimming pool.
Absolutely, okay. Because if a kid gets into a pool area and gets in the water, they can actually drown, or there could be a lack of oxygen to the brain, which causes some brain damage. Agreed. Did your
Agreed.
folks not have a fence around this pool? Okay, no, I'm joking. Let's carry on. All right, so here we go. So here's our pool. You'll see it's got a whole lot of measurements to it, and we've got this area around here. Now, here's the question. Consider the fence surrounding the pool and the paving area. So the question is saying, oi, look at this fence. Here it is here. Okay? This pink thing that I'm busy drawing. That's the fence, and this is what we've got to consider. And here it is. Determine the perimeter of the fence. Now, guys, that looks like a very straightforward question, because all we've got to do is take the length of the one side of the fence, add the breadth, add the length, add the breadth. And so we've got the perimeter of the fence. Easy, James?
Easy, easy.
Okay, so James is going to do it for us because it's so easy. Right, James, first thing then, here we go. What is the breadth of this fence?
Well, they don't give that to you on the fence.
Ah, they don't give it to us. So what are we going to have to do?
Well, you can see that the breadth on the swimming pool, on the rectangle on the left there, is 5.5 meters.
Cool.
From the space of the top to the fence, the top left corner, is 1.5 meters.
Brilliant.
And is it also on the bottom?
It is indeed.
So then, add those together and you'll get 3 meters.
Okay,
So
let's do that. We're going to say we've got 1.5
5 plus 1.5.
plus
5.5.
nice 5.5, and we get a breadth then of
8.5 meters.
brilliant. So James, we've got a breadth of 8.5 meters.
Yes.
Now we're going to do the same thing with the length of the fence, aren't we? We're going to
Yes.
find all the bits and add them. So it's straightforward. Let's do it. Okay, so what's the distance from this point over here to this point, James?
That's 1.5 meters.
Absolutely brilliant. 1.5 meters. Straightforward, hey?
Straightforward.
And from this part of the pool to this part of the pool is?
9 meters.
Brilliant. Straightforward, hey? Not hard at all.
Not
Okay.
hard at all.
Now, from the end of the fence to the beginning of the pool is how long?
From the end of the fence.
Fence
Oh,
to-
sorry. It is 1.5 meters.
Brilliant. 1.5 meters.
Yes.
Nothing hard about that.
No, I
okay.
think so.
Now, James, what is the length between this part of the pool and that part of the pool?
1.5 meters.
1.5 meters. Absolutely wrong. Eh? Okay, why is it wrong? James, how can we possibly find the length from here to here? Now, if I do it there, you can see straight away that this is a
Perpendicular height.
or a radius.
Okay, yeah, the radius, yeah.
That was the next thing you were going to say, wasn't it?
radius sounds the same, so I got them mixed up as perpendicular. Sorry.
Perpendicular sounds the same as radius. You know,
It,
sometimes it's good just to...
Yeah.
Okay, right, so, now James, this is what I need to ask you. What is the diameter of this pool?
That is 5.5
Brilliant.
meters.
So what is the radius of this pool?
5,5 divided by 2.
Okay, I love it when you say like that because it means you actually can't work it out. All right, so let's do it. 5.5 divided by 2 equals
2.75
Brilliant.
meters.
So I know that this radius is 2,75 and this part here is 2,75. So James, what is this radius?
2,75.
Absolutely, hey, because a radius is the same thing all the way around a circle. Okay? So if you can pretend that I've got a circle here. James, come stand next to me. Okay. So
Okay.
what are you doing?
I was
Ballet
making a
dancing.
circle.
Are you making a circle? All right. You do the ballet thing then. All right. Okay, so there it is on your toe. No, I'm joking. All right. So if I were to say that this were the center of the circle, okay, from the center to the radius is the same, to the circumference is the radius. That would be the same distance as from the center of the circle to this circumference, which is also the radius. So no matter where I go, I'm going to have the same length. Would you agree on that?
Mm-hmm.
Looney?
I'm sure I do agree. Yeah.
Okay, you would agree. All right, you can go away. Now, in the same way, this is 2,752. That's also 2,75. So the length here is 2,75. All right, so let's add all that up, shall we? So we've now got, let's go for it.
1.5,
Yeah,
1,5.
plus,
9
cool,
plus
okay, let's go this way.
2,75.
2.75, nice, plus
1.5.
1.5 equals
14,75 meters.
14,75. So I now know that this whole length is 14,75 meters. Now, folk, I can now look and try and figure out the perimeter of that whole rectangle. How do we do perimeter? We just
Add up all the sides.
Absolutely. Okay, so my length is 14,75, my breadth is 8,5. So let's get out our calculator again, and we're going to say we've got 14,75 plus 8.5
plus 14,75 plus 8,5.
Cool. And James, that gives me an answer of
46,5 meters.
46,5 meters. Okay. Now, for those of you out there who thought, gee, finding perimeters straightforward, it's easy. You can see from that question there was a lot of work involved with that. It wasn't straightforward of just saying, well, let's add up the length, the breadth, another length, and another breadth. Not at all. It was a case of saying, sure, we've got to actually calculate the length of that breadth. We've got to calculate the length of that length in order to work out the perimeter. And so that gave us a bit of rough work, and I think it gave you a little bit of a headache there, didn't it?
Never, sir.
Okay, next question. Now, determine the cost if the fencing is sold in 5-meter strips for 162 Rand 50. Okay, so we now want to work out the costing. How much will it cost to fence that pool? But we're told that fencing is 162 Rand 50 for 5-meter strips. So where we buying our fencing from, they don't have fence where you can just buy a whole whack. They've got it in 5-meter strips. Okay? We must be in a very small town.
I think so.
They've only got 5-meter strips of wire. That's all they've got. Now, what's the first thing we've got to do, James, before we work out the cost?
Let's find the cost of 1 meter.
Well, we can only buy 5 meters. We're going to work out how
awkward.
many.
How many strips you gonna need?
Absolutely, hey? We got to find out how many strips are we going to need. So what we're going to do is say this. Our fencing was 46,5 meters. That's how much we need. We want to work out how many strips we need. And each strip, James, is?
5 meters.
So we're going to divide it
that
by
5.
5 meters. Okay, so let's do that. Out comes our calculator. We still got 46,5. We're going to divide that now by 5, and we get an answer of 9,3. Okay, so we got 9,3 rolls of wiring that we need, or for 9,3 strips. Would you agree? Okay, Lenny, I'm going to ask you something here now. Keep you involved with this whole lesson. Here we go. I need 9,3 strips. Is that answer good enough?
To answer the question,
Yeah.
no.
No, it's not. Why not, Lenny? Should we elect James answer
Yes,
that?
James.
Okay, James, why not?
Because you can't have comma 3 of a strip.
Absolutely.
You
hey.
have to either-
We got to buy the whole strip. In the same way, I can't walk into a shop and see a chocolate and say, "Whoa, that looks good." But you know, because of my phenomenal figure, all right, this is not a joke. You can stop laughing. Because of my phenomenal figure, you can see I don't eat a whole bar of chocolate. I only want a little piece. I can't go in that shop and break part of that chocolate and then go to the counter and say, "I just want this little bit." Okay? We're going to get some very irate shop managers here with us. Right. My wife, she can eat a whole lot of chocolate, but me, only a little block at a time. Right? So, can't buy bits of things. If I walk into a hardware store and I see a whole lot of fencing and it's in a roll, right? And they're selling all these 5-meter rolls. I can't say, "I don't want the whole thing. I'm just going to sit there with the scissors and cut it." I'm going to get into some trouble. So, James, here's the question. I now know I've either got to buy 9 or I've got to buy 10 rolls. So I'm going to ask Looney again because she's engaging quite nicely with us tonight, which is quite exciting. Looney, am I, now 9,3, we've got to round it. Do you agree? So am I going to buy 9 or am I going to buy 10 rolls?
Well, when you round off 9,3, it's 9. But then now you need that 3 strips. So I'd get 10 so that I'd get the 3.
Absolutely, hey? We have a genius in our midst.
We have a
Okay.
winner.
Folks, if I buy 9,3 rolls, I can't do that. We've already said that. So I've got to buy 9 or 10. If I buy 9 rolls, there's 3 missing. Would you agree? So let's say I have a fence, and in that fence I am fencing. What would we fence? What sort of animal?
Chickens.
Chickens. Okay, there we go. Thanks, James. We've got chickens, and we make a pen and we fence these chickens, and we say, if I buy 10 rolls, I'm going to have a little bit too much fencing left over. If I buy 9, I'm not quite going to have enough, right? You're not going to buy 9, because if you buy 9, there's going to be part of the fence that's not going to be fenced in. And what's going to happen, James?
Chickens and run away.
Absolutely. It's going to be chicken a la happy, all right? Because the chickens are going to get out, right? So we need to close that. It does mean we're going to have a little bit of extra fencing, but that's okay. All right, so 10 rolls. But now, we haven't answered the question, because the question is, how much is it going to cost? James, if every roll costs 162 Rand 50, we're going to times that by 10. Would you
Right,
agree?
sir.
So when I times that by 10, I'm going to say my fencing costs 1,625
Rand.
That's how much it costs to fence it. Agreed?
Agreed.
Okay. Now, we come to another question which always causes major, major frustration with so many students. And what we're saying is this, that folk, if I have a fence, and if we go back to the question, we can actually see that the length of the one side of our fence is 14,75 meters. Now that's pretty long. Now there's no way I can put a pole over here on the edge of my fence, okay? Put another one pole, let's say that's a pole, put a pole 14,75 meters away and expect that fence to stand upright. It's going to start sagging in the middle, okay? Have you ever seen a sagging fence?
I have. Sir.
All right, absolutely, so have I. Okay. So what are we going to put in the middle to stop it from sagging?
We're going to put poles in the middle.
We're now going to put poles up so that it holds that fence nice and firm. All right. Now, the question says this. Determine how many poles are required to hold the fence if the poles are to be spaced with a maximum space of 1,8 meters. Right. That means, folks, from the corner, obviously in the corner I'm going to have a fence. I've got 1,8 meters to my next pole. Then another 1,8 meters to my next pole. Then another 1,8 meters to my next pole. Now guys, there are a whole different ways of doing this. I'm going to do the most practical way. I'm going to sit with my calculator and I'm just going to make marks and keep adding 1,8 until I reach 14,75. James, I'm going to need you to help me out here, so let's just bring up the calculator. So what I'm going to do, James, I'm just going to keep adding. All right, so we got 1,8, and there's our first pole. Agreed? Oops, when I do that, your calculator disappears. Okay, right, plus, now, we're going to add another 1,8. Okay, 1,8 equals, oops, here we go, 0.8, oops, 8 equals, right, 3,6. So that takes me to that pole. Right. So we've got on our calculator 3,6. We haven't got to 14,75. Add another 1,8 plus 1,8 equals. And what do we get?
5.4.
5.4. So there it is. But we haven't got to 14,75. Okay, quick. Let's add 1,8 equals. Okay, 7.2. Haven't quite got there, but we're halfway, and that's encouraging because I think our producer's thinking, how long is this going to take? Okay, we got to 9. So that takes us to 9 meters. Right, again, James, plus 1.8 equals, and we get
10.8.
10.8. Okay, we're getting closer. Right, let's add another 1.8 equals
12.6.
12.6. Right, well, we need another pole. Here we go. Plus 1.8 equals 14,4. Okay, now, stay here, James. Guys, 14,4 is very close to 14,75. But it hasn't got there yet, has it?
No.
And if we don't put another pole in, that fence is going to
flop.
Okay, so we're saying we've definitely got to put in another pole. Now, what would happen if we added another 1.8?
It would go over the length of the fence.
Absolutely, let's see it. Plus 1.8 equals, and we get 16,2. So our next pole would be way out there, which we don't need. We just need the one on the corner. Now, guys, how many of you have actually seen a fence where you've seen a corner pole and then you've seen another pole pretty close to it? Have you ever seen that? Have you ever seen that?
I have, sir.
Come stand close, I'm not going to hurt you.
I have, sir.
All right, so, not that close. All right, so we have a pole in the corner, and then there's another, make a corner.
A corner.
A corner. Okay, yeah, he's got a corner like this, right. So we got a pole on the corner here, right? But then sometimes we've got another pole very close to it, because if we don't have that pole, the distance between our previous pole here is going to make the fence sag. Got it? Okay. Thanks, James.
Yes,
so,
sir.
now, do you agree whatever happens that side happens this side?
Yes, sir.
Got it, because it's the same length. So we got 1, 2, 3, 4, 5, 6, 7, 8 poles there. 1, 2, 3, 4, 5, 6, 7, 8. Plus we've got to have our corners. Eh? If we don't have our corner, we won't have a corner.
Exactly, sir.
All right, the fence won't go to the corner. It'll cut in. Right. James, we've got to do the same thing. I need you back here. Because now we've got 8,5. Let's just clear that, right? And we said 1.8.
8.
Okay, get rid of that. All right.
Up.
Okay. 1.8. Right, and that takes us to over here, right? Then we add another 1.8 and we get
3.6.
3.6. We're going for 8,5.
8.5.
Okay, cool. So another 1.8 equals 5.4. What are we going for?
8.5.
8,5. So let's keep going. Plus 1.8 equals
7.2.
7.2. We're going for?
8.5.
Let's go. Another 1.8.
1.8.
9. Ah. Where's that pole going to be, James?
Out the box.
Out the box. So as long as we've got that corner one, we don't need another one in there.
Yes,
all
sir.
right. So James, how many poles do I have? 1, 2, 3,
4.
and I'm going to have to do the same this side. Agree?
Do we
1,
count this corner
2,
one?
3, 4. When we add up all the poles, we've got to count them.
Oh, okay.
Okay, cool. All right. So, James, from over there, let's go. Let's count, because you can see it better from further. I'm too close to the screen. Starting from here, make that 1.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28.
28 poles. Okay. So we need 28
8 in
poles.
total.
Now the question is this. I need 28 poles. Now I've got to buy them. I can either buy them in groups of 6 for 500 Rand, or I can buy them individually for 98 Rand. Which would be cheaper, buying them all individually or trying to buy groups of 6?
Well, we're going to have to find out.
Well,
so.
let's find out. Okay. So what we're going to say is if I buy groups of 6, 500 Rand divided by 6 is going to cost me how much, James?
83.3
It works
Rand.
out to 83 Rand, 33 per pole.
Yes, sir.
Agreed? But if we do buy them individually, it's going to cost us 98 Rand. So, folk, we're going to try and buy as many groups of 6 as we possibly can. All right. So, how many 6s will fit into 28?
Only 4.
4. Okay, cool. So, because 6 4s are 24. Absolutely.
24.
All right. So, we've got 4 groups of 6. And that's going to give me 2,000 Rand. Then we need how many more poles, James?
4.
Another 4.
Four.
Because we've got 24, 25, 26, 27,
27,
28.
28.
We need another 4.
So we're going to have to buy them as the singles.
Do we buy another group of 6 and have 2 left over? Which would be cheaper? If I bought 6, it's going to cost me 500 Rand. If I buy 4 individual ones,
It's going to cost
4 times 98, it's going to cost me
392
It
Rand.
works out cheaper, doesn't it? So we're going to say, let's rather buy 4 individuals at 98 Rand. And what was that again? 300 and? Let's just bring it up here.
92.
392
Rand.
James, which gives us a total of?
2,392 Rand.
Absolutely.
Comma 00.
So that's how much the poles are going to land up costing us.
I think it's time for a break now. Don't go away. We'll be right back. Welcome back from the break. Let's not waste any time and get straight back to today's revision lesson. Over to you.
Question number 1. We have got a water tank. Now, for some reason, it's jumping, but hopefully it doesn't jump too much. There's my water tank. It's illustrated above, and we're told it has a height of 2,75 meters. It has a diameter of 1,8 meters. So guys, let's think this through. We know it has a height, vertical height, and we've been given the vertical height. I like to put the vertical height onto the diagram, and I'm going to be, so I don't get it confused. Height goes up 2,75 meters, and I want the diameter. Now, as soon as I see diameter, I don't really like to work with diameter. I like to work with radius. So what I'm going to do is I'm going to go to the board, and I'm going to, on the diagram, and you can do this in when you're doing your exam, write it down on the diagram or the sketch that you've been given. What is the radius? We don't know at the moment. We know that it's half of the diameter, which means that it's half times the diameter, which was 1,8 meters. So let me go and make sure that I've got a calculator to work that out. And I'm going to say I want half times 1,8. Now what do you think 1,8? 1,8 is close to 2. So half of 1,8 should be close to 1. You agree? So estimate it. We think it should be close to 1. Let's see what it is. And we get a 9 out of 10, which is close to 1, which is 0,9. So we recognize this is 0,9. So now I'm ready. Check that it's meters. Check it's meters. Got it all right. So we're in the right range here. Due to the fact, question 1, that the water tank is looking shabby, Joe decides to paint the tank a lovely blue color. So, the question is, what surface area needs to be painted? Remember that there is no need to paint the bottom of the tank, as lies on the floor. However, the top and the sides need painting. So, let's have a look at the picture again. And what you'll recognize is this is a water tank, and somehow it's collecting water. There might be a pipe going into it, but there's a top to it. It's sealed, and it needs to be painted a blue color. The reason that the top is there, so the dust and other stuff doesn't get inside, keeps the water clean. And we've got to paint all the surfaces. So really what we want to do is we want to paint the one circle top bit, and we want to paint the round bit. So just like this, we want to paint a top bit, and we want to paint a round bit. So let's think about that. If we draw a picture of this thing and lay it out, what we will have is the top bit, which is the circle, and then a square bit, which is like that. Now, guys, the question is, how long is the top bit? How long is that bit that goes around, the curved bit? It's curved over there, but how long is it over here? Well, the good news is that distance that I'm showing you is exactly the same as the circumference of the circle. The circumference of the circle, remember, is 2 pi r. Okay, and we know the height. We know that height. We know the radius of that. We've worked that out already. So I think we're ready to go. We can work out the diagonal. The way I'm going to do it is I'm going to break it apart into 2 bits. And I'm going to say, what is the area, first of all, of the top? Of the lid, if you like, and that circular bit. So we recognize that the area of that is pi times r squared. And pi is 3,14 times the radius, which is 0,9, and we want to square that. Let's get the calculator up to do that. So there we've got the 0,9. We're going to square it. So we're going to say that's squared times pi, which is 3,14. And there we go. We've got the area of this bit as being 2,54 meters squared. 2,54 meters squared. That was just the top bit. So what about the sides, the curved side now? Right? Remember what I said to you? When I drew the little net to break it apart, to cut it apart, we recognize the length of that top bit is the same as the circumference. So we're going to say it's length times breadth. So the area of the curved bit, the area of the rectangle of the curved surface is going to be its length times the height, and the length in this case was just the circumference, which is 2 pi r times the height. Now 2 pi, 2 times 3,14 times r, which was 0,9, times the height. Let's go back to the question to get what the height is. We were given the height of 2,75. 2,75. Now, there we go. Clear that for a minute and let's get it in. We're going to go 2 times 3,14. Now look at that. I didn't put the 1 in. 3,14. We'll just make sure it's in now. 2 times 3,14 times 0,9 times 2,75. Check that I've written it down right. Remember, in this formula, we're just working for the circumference. There's no squaring in it. So we're all okay. And we put the answer down, and we see that it's 15,54. 15,54 meters squared. Now guys, we can't just leave it like that. We've got the top bit and the side bit. What have we got to do? We've got to add them together. So that's not difficult. Let's just take the calculator and say, let's add plus 2,54, which is the top bit, and we get an answer of 18,08. And if I was rounding off to make it practical, just the amount of paint, so the total surface area that I'm going to need is 18 meters squared. So we know that it's about 18 meters squared, 18,08 meters, or 0.9 meters squared. And what we're going to do, we're going to work with 18. It says how many liters of paint are required if 1 liter can cover 4,5. Well, that's easy. We know that 1 liter of paint covers 4,5 meters squared. Now what we've got to do is say, how many times does 4,5 go into the 18 meters? So it's not that difficult to work that out. We're going to take our 18 meters squared. We're going to say 18 divided by 4,5. Now, every time it goes once will be 1 liter. If it goes twice, it will be 2 liters. If it goes 3 times, it will be 3 liters. If it goes 4 times, it will be 4 liters. Let's think about it. How many are we expecting it to be? Well, think 4,5 is close to 5. And 18 is close to 20. So 5 into 20 goes 4 times. I think it's about close to 4 times. And I think it might be the right answer as well. There you go. Now let's think, how did we get that? We've checked it, we estimated it, and the calculator tells us 4. Does it make sense? Let's count it up. 4,5 plus 4,5. What does that give us? 9. So 2 times 4,5 is 9. And 9 into 18 goes twice. So it all works out. It looks right. 4,5, 9, and then 13.5. And then 13.5 plus 4,5 will give us 18. So what we're recognizing is that we would require 4 liters to complete this painting. 4 liters. Just 4 liters. So now the local paint store sells this specific color in 5 liter cans. Each costs 439 Rand. What will it cost to paint the entire water tank? Well, guys, it's not difficult. We've recognized we only need 4 liters. Okay? We had a little bit left over, the 0,9 there. But do you think that's going to make that much difference? Well, let's check it. In our rounding, let's check it, that we can make absolutely sure. We had 0,8 something divided by 4,5, I think it was. 4,5. And I don't think it's going to get to another liter. It's not going to take up another liter. But let's just be absolutely sure on ourselves so that you can see. And you can see that it comes to that 4,01. You can see the rounding effect is not that big. Now we've got 4 liters we need. They can't sell a 4 liter the paint of this color. Sure, you might be able to get 2 liters, or in some cases you might need to buy 4 1 liters. You might have to evaluate what's the best deal from the paint store. Or you can buy a 5 liter, which is going to cost this amount, 439 Rand. And so I think that all we're going to do is to spend the cost of 439 Rand. Why? 1 tin of paint. We just need 1 tin of paint. Tin of 1 5 liter tin. 1 5 liter tin of paint, which is going to cost us exactly 439 Rand. Okay. Now, there is another question that's part of this whole question on the paint and the water tank. But it's slightly different because it's not dealing with surface area. And I want you to be very clear about it. We've put this question in because we want to make a difference between what goes on the outside and what goes on the inside. we're not going to put paint on the inside of a water tank. We're going to put paint on the surface of the water tank. But we're going to put water on the inside. We're counting how much water will this tank hold. We're now not talking about surface here, we're talking about volume. And volume is always measured in meters cubed or centimeters cubed. It's three things multiplied together. It's not just a length times breadth, but it's a length times breadth times height. So let's look at the next question and let's see if we can do it, because it's quite interesting. It says 1 liter of water takes up the space of 1,000 centimeters cubed. Yeah, 1 centimeters cubed is the same as a milliliter, and 1,000 millimeters makes up a liter. Okay, now we've got the surface area. Remember, we've got the surface area of the whole thing, and we've also got the area of the top bit, and we've got that. So now what it says is determine how many liters can fit into the tank if it is 95% full. Now let's just go over the idea of volume. So guys, what we need whenever we're doing volume, even if it's a cylinder, like something like that, we're going to take the base area, which we've already calculated, it's that area, multiply it by height. So let's go to our calculation back up there, and remember we calculated it and we said the area of the top, which is the same as the area of the bottom, is 2,45 meters squared. It's 2,45 meters squared. So this area is equal to 2,54 meters squared. 2,54 meters squared. And we were told that the height, be very careful now, the height back at the top of the question was 75 meters in length. Okay? 2,75 meters in length, not 75 meters, 2,75. Just check it. 2,75 meters. Now, what are we going to do to work out volume? Very easy. We're going to take the area of the top and we're going to multiply it by height. And you're saying to me, but this is so easy. And it is. It's straightforward. But let's not get too carried away with ourselves, because there is a little trick to this that I am seeing, and I want you to be aware of it, and you must be thinking about it. I'm doing it one way, and we're going to check it just now. So I'm going to take the area of the top, and I'm going to multiply it by the height, which was 2,75. And guys, when you do that, we get this answer. We get the answer of 6,985. 6,985. But this is meters times meters times meters, so it's meters cubed. Sure, that's a very, very big amount of stuff, because it's meters cubed. Now, what you weren't told in the beginning of the question, you might need to remember, is the following conversion. And there, as I said to you, there are two ways of doing this. What you need to remember is that 1 meter cubed is equal to 1 kiloliter. Okay? So if we want to convert this, because they've asked us how many liters were there, not how many kiloliters, then we're going to have to take this amount and say that's the volume. Now we want to work out how many liters, what's the capacity, how much could it hold? It could hold this amount in not just liters, but those are kiloliters. We want to change it to liters. So we're going to take the 6,985 and we're going to say that was kiloliters, and we want it to be equivalent to the liters. So we're going to multiply it by 1,000. So I'm going to take my calculator, and that's what we've got on the board there. We're going to multiply this by 1,000. and we get the answer of 6,985. 6,985 liters. But guys, that was the total. That's if it was full. It's not full. Remember what it said. The question said, and it's a tricky little thing, it's only 95% full. And what does 95% mean? It means 95 over 100. So then the amount of water is equal to 95 over 100 multiplied by 6,6985 liters. And let's just do that. We can get an answer multiplied by 95 divided by 100 equals, and there we go, 663575. 6635,75 liters. And that's it. Please understand that's what goes in. Now we're going to be doing more volume calculations next week. Please make sure that you understand it's not the same as surface area. But often in questions they combine the two so that you can distinguish between the difference and you can be assured that you've got them.
James lives on a farm. He relies on a water tank to keep drinking water for his chickens. The water tank, as illustrated above, has a height of 3 meters and a diameter of 2 meters. Now, James, if you read that in the exam, what's the first thing you're going to do?
Highlight the values.
Okay, let's highlight the values. 3 meters and 2 meters. So we told this thing has a height of 3 meters. We told it has a diameter of 2 meters. If it has a diameter of 2 meters, James, what are we going to say?
It has a radius of 1 meter.
Nice. It's got a radius of 1 meter. And I always say to the chaps in my class, guys, the word diameter is like a swear word. We don't use it. So if you see diameter, get rid of it and write radius, because radius tends to come up a lot more in formulas than diameter does. Okay, so here's the question. What is the volume of the water tank? Remember that volume of a cylinder is pi times r squared times h. Okay, James, so pi we know is
3,14.
nice, and you should know that, guys, all the time, right? That should be something you just know. It will be given to you in exam, but it's so much easier and you feel so much confidence if you know these facts. So 3,14. What is my radius, James? You did say it. We've got a diameter of 2,
1
so my
meter.
radius is?
1.
1 meter. Fantastic. And
Square.
what is my height?
Your height is 3 meters.
Great. Okay, so out comes our calculator, and we're going to say we've got 3.14, multiply that now by 1 squared, multiply that by 3, and we get an answer of
9,42
9,42
cubed.
Nice. And again, emphasis on the cube. Why?
Because it's volume.
Because we're dealing in volume.
We've come to the end of today's show. Thanks for joining me and for chatting to me during the show. Remember to visit our website, learn.mindset.co.za, to get the notes and to watch the videos from the term. Goodbye.